Hello and welcome to my continuation of that lesson. In a previous lesson, we looked at the fourth objective, which was stationary points and curve sketching. This point we complete with doing the portion that had to do with the curve sketching, and so we need to begin. Curve sketching. Now we have the following questions that I want us to try. Hopefully they'll be helpful, and so let's begin. We have the first question: y is equals to, you can read it there. I must mention that it's good for us to express this as a polynomial, as I have expanded there. What I mean is just expand these ones, so that you have it this way. We'll need it to differentiate. And I must say that according to previous lesson that I mentioned the following, that when you are sketching curves, you need the x-intercepts, the y-intercept, normally 1, and we need the turning points and their nature. And so we just go down those three. If you have those three, we'll be able to sketch almost any curve. And therefore, we begin with this. We look for the x-intercept, therefore, and the x-intercept is actually the place where y is equals to 0. So you just put y is equals to 0 for this equation. This one is easier for us to work with because we, at this level, do not know how to solve a cubic equation, which is written in this particular manner. But when it's factorized, we have a quadratic equation times a line equation. We can always solve. And so we get the values of x there is 3, 1, or 0.5. So we have 3 points where this curve touches the x-axis. It's a 0.3, the 0.1, and the 0.5. We need the y-intercept. Where does the curve touch the y-axis? And therefore, the y-intercept is where x is equal to 0. So put x is equal to 0 here, and you get y would be -3. Therefore, we know the curve touches the y-axis at the point -3. We now turn to the turning points. The turning points, we just follow the concept that I tackled in the first lesson. And so what we do is we look for the first derivative, equate it to 0. And in this particular case, we now use this one here to differentiate. We get 6x squared minus 18x plus 10. That one equals to 0. So solving for the values of x, you get either the two answers there, 0.7 or 2.3. What are these? These are the values of x at turning points that the curve is having. The curve takes 2 turns. One at the point where x is 0.7, the other one is at the point where x is 2.3. Now when x is 0.7, y is 0.3. That is, the turning point is therefore 0.3, 0.7, 0.3. Then when and if we testing that, we take the second derivative, differentiating this further, and putting the value of x to be 0.7. This value got here, we get the answer is negative 9.6. And now that it's negative, it must be a maximum point. The point 0.7, 0.3 is a maximum point. We have the first point, and we have known it's a maximum point. The next thing, we look for the value of y when x was 2.3. When x was 2.3 is a turning point, we want to find the value of y. So y is -3.3. Remember that you're supposed to put the 2.3 on either this equation or the other one, and just solve. So we have a turning point at that particular point, 2.3, -3.3, and testing it, we put it to test by taking the second derivative of 6x squared minus 18x plus 10, just deriving this one or differentiating that further, we get 12x minus 18. So we put the value of x to be 2.3, the answer will be 9.6, and therefore, since it's positive, it becomes a minimum point. The point 2.3 minus 3.3 is a turning point and a minimum turning point in that matter. We have the things that we now need so that we can sketch the curve. This is what we do. We just need to plot all that information we got in that calculation for the intercepts and for the turning points on a sketch on the Cartesian plane. We just have the x and y axis, and you just put the information. For example, the x-intercepts, we have 3, 1, 0.5. So we have 0.5, we have 1, and 3. Those are the x-intercepts. We know the curve is touching the x-axis at those points. The y-intercept is -3, so it is touching the y-axis at that point. What about the turning points? We have a turning point at -0.7, 0.3. Now you must know that these turning points normally are placed somewhere between some two x-axis intercepts, and therefore the 0.7 is somewhere between 0.5 and 1. No wonder it's this point here. This is 0.7, 0.3, which is rounded off to 0.7, 0.3. the figures you have there. Then the other one is a turning point is 2.3 negative 3.3. That one, remember, it's now between this point and the next one. You see, 2.3 somewhere between 1 and 3, and therefore it's a pillar point there. So what do? We just plot the curve, and the basic question would be, how can a curve move pass here, and all of these points, and only has how many turns? Because it's cubic equation, we should have only 2 turns. How can it be? And how can it also have a maximum point at this point and a minimum at this point? It means it's just going upwards that way, and then downwards that way, turning to go up again. And that's on your screen there, and it's it. Let's turn to the next question. We have y is equals to x raised to power 4 minus 16x squared. Therefore, we look for the intercepts. X-intercept is where y is equals to 0. Put y is equals to 0. Solve. You can factorize this. I think it's necessary for us to solve that way. So factorize out x squared. You get a repeated root. The x squared gives us x equals 0. This means it's 2 points. All right. X is equals to 0 and x equals to 0 again. The other one, you need to take 16 the other side. Notice that the square root of a number in mathematics is plus or minus. Therefore, we're going to have since 0 is equals to x squared minus 16, taking 16 the other side, you get x equals to negative or positive 4. So we have 3 points where the curve is touching the x-axis. The point 0, which seems to be a turning point already, and negative 4 and 4. And they are listed there. All right. The y-intercept. Now we have this where the x-axis is 0. So putting y is equals to 0 in the equation, the equation given at the beginning, y is 0. So that curve only touches the y-axis at the origin, 0, 0. The turning points now. We look for the turning points. We assume we expect to get 3 of them because the highest power of x here is 4. So the turning points normally, the number of turning points is normally n minus 1, where n is the highest power of x, or order of polynomial. So first derivative, changing y or changing x is equals to 0. So you just differentiate that. You get 4x squared minus 32x. Sorry, 4x cubed minus 32x. And if that is equals to 0, simplify. You divide, you factorize out 4x. So you get x squared minus 8, and that way. So we have 4x equals to 0, which means x equals to 0. Or we have x squared minus 8 is equals to 0. Therefore, taking 8 the other side, you can have x squared is equals to 8. Find the square root of that. It'll be negative or positive. So we have the turning points happen at the point where x is 0, x is equals to negative root 8, or root 8. I've used the roots because they're easy to understand or to figure out. Now we go to the nature of turning points. The first point, when x was 0, we had y is 0. Why? When you put x equals 0 here, you get y is equals 0, and that's the point why we had y is 0 here and another 0 for x. So that's a point there. So we have a turning point at the point 0, 0. When x is negative root 8, this one here, just put it on this equation and raise to power 4. Now that is a negative number. First of all, it will be positive at the end of the day. The other thing, because the square root raised to power 4 is same as the 8 squared, which is 64 minus the other one, which will be 16 minus 16 times 8. So just simplify that. I guess you should be able to do that. You get y is 64. So we have another turning point at the point negative root 8, 64. The last one will be, we have 8 there, root 8, sorry. Just simplify, you get y again is 64, and continue, you get those 3 points. So we have turning points at those 3 points. We don't know their nature though, and so we get to that. The nature of the turning points we'll need to test using the second derivative method. So differentiating this further, the first derivative was what was that? It was 4x cubed minus 2x. So differentiating this further, you get 12x squared minus 32. And we know if the second derivative is negative, it's a maximum. If it's positive, it's minimum. If it's 0, point of inflection. So we get that. So for the point 0, 0, putting x is equal to 0 in this equation, you get 32, negative 32. So it's negative, it means it's a maximum point. That's easy. The next one. The next point is negative root 8, 64. So putting negative root 8 on this equation here, we get, the answer is 64, positive. That means it's a minimum point. All right? I think that's easy. The next one, The third point is root 8, 64. So putting that root 8 on this second derivative equation, you get the answer is 64, and it's a minimum point again. So you have maximum, minimum, and minimum, but notice that they are in this order. The negative 8 is to the leftmost, the 0 is at the center, and the positive root 8 is on the other side. So that already gives you a picture. Now, what we are supposed to do is we plot this kind of information we got here on a Cartesian plane in a sketch, and now we start thinking about how the curve should go if it touches those points that you have plotted. So the points are these ones here. The x-intercept points, we have -4, 0, and 4. We have -4, 0, and 4. So the points we got, that's where the curve cuts. The curve cuts all the y-axis at 0. Again, that same point, all right? And not only that, we have turning points at the point 0, 0, the same point. There's a turning point here, which is a maximum point. That means it's going out that way. That already answers the question, therefore. Since the curve goes that way, it must be coming from this point going down, so that it turns that way and comes up that way. Besides, the point root 8 is down here, so that is this turning point, negative root 8, 64, is down here, and positive root 8, 64 is down here again. Therefore, and they are minimum points, yes. So that actually confirms what I just said there, and therefore, if you just plot that, it will be like this. Remember, again, you don't need to have the scale when you are sketching. You just need to have the necessary points: the x, y-intercepts, the x-intercepts, the y-intercepts, and the turning points, and just curve as we have done there. I think we move to the last question. We have it there on your screen. Please expand it until you get this. It's a cubic equation. We expect to get 2 turns. Yes, we need to get 2 turns. And so let's begin. The x-intercept is where y is equal to 0, put y is equal to 0 in this equation, and so we get the values of x are, and by the way, I should mention the way it was given, which was written this particular way. It's written for you that way so that it's possible for you to solve. When it's this way, it's not possible for high school level students to solve, because you don't know how to solve cubic equations when you're given this way. But for post high school, you can always do that. So it is given that way so that you use this one here to solve the value of x when y is equal to 0. Therefore, we say 0 is equals to x plus 5. Again, therefore, x is equals to -5. Or we have x squared minus 5x plus 6 equals to 0. So solving the value of x there, you get x equals to 2 or 3. So what do we have? We have turning points at the point -5, 2, and 3. Those are the points where the curve touches the x-axis. Where does it touch the y-axis? The y-axis is where the x is equal to 0. Therefore, putting the values in this equation, or even the other one now, putting is equals to 0, you get y is equals to y is equals to what? What is it? I think 30. Yes, y is equals to 30. So we know where it touches the y-axis also. We now go to turning points. We have turning points. How many? 2 of them. And so we're going to determine. How do I know there are 2? Because the number of turning points normally equals to n minus 1, where n is the highest power of x. This is a cubic equation. That means n is 3. The number of turning points is 3 minus 1. Therefore, we look for the first derivative, equate that to 0. And since this equals to 0, you can solve to get the values of x. And x will be, just solve, you'll get -2.52 or 2.52. So we have, these are the points, the x coordinates, where we have turning points. Now, when x is -2.52, putting that value, this value here, in the original equation we had, either this one or the other one there, you get the value of y is 61.88. The next thing is, we have that coordinate. This is a turning point. We don't know the nature yet. When x is 2.52, again, putting this value here, 2.52, on the original equation we had, we get y is equals to -1.88. Therefore, we have a turning point at the point 2.52, -1.88. And therefore, these are the turning points we have. What about their nature? Going to their nature now, we look for the second derivative. Differentiating this further, it will be 6x. All right? And so let's pick the first point. The point is -2.52, 61.88. So putting -2.52 on here, we get 6 times the negative of that. The answer is already negative, so we know it's a maximum point. I think that's easy. We go to the next point, which is 2.52, -1.88. Putting that value in the second derivative, 6x here, putting x to be 2.52, again, it'll be a positive number, obviously it'll be a minimum point. Now, we now put all this information we've got in a sketch on our Cartesian plane, and here it is. The x-intercepts, we had -5, 2, and 3. So we have -5, we have 2, we have 3. The curve is touching those 3 points along the x-axis. The y-axis is touching it at 30. We have a turning point at the point, a maximum turning point at, where was that? -2.5 to 61.88, and therefore it must be between the first and the second x-intercept, and it's that point there. All right. So we already have an idea of how the curve goes. Since this is the maximum point, this other one is a minimum point, the curve must be going up to touch that highest point and going down to touch that lowest point and coming back to 30. I think that's easy. So if you can drop the curve, we have it there, and it should be that way. Let me repeat, you don't need to have these x and y values, you just need to have the necessary points. The intercepts, this point and that point, that point and that point. We also need to have the turning points, and that's that. I hope you find that helpful. It's been comprehensive, and I think it's helpful. So please like, subscribe, share, and I appreciate any feedback.